session ends in 5 minutes.
Okay. We're not going to have a break. Yeah. No, it's fine. It's fine. It's 2 o'clock. We have 1.5 hours. 140 minutes. Okay. Finish the session. Can you do that?
Okay, guys.
We'll give you a break of 5 minutes. Until 4.
So let's just have a, we won't go into the second talk quite just yet. We're going to look at this slide in a second, but there's a lovely point that Uncle Rutford made to me earlier that I won't put it as well as he did, because it's a very deep angle, but when we present science, we're not trying to say that science validates the Bible. We're trying to say that the Bible and God, if I'm speaking to someone who is an atheist or trying to understand something myself, I can use science to help understand something that the Bible already understood, that religion already taught. I'm not putting science above the Bible to try and say, well, that's why the Bible is correct, because science itself has validated it. It's actually the other way round. And already, Uncle Rutford, I've probably messed up your point, but do you want to elaborate on that more?
No.
Thank you so much, but please, guys, Bible, God, science down here, Bible and God up there. Over time, science will begin to understand more of the realities of God, but actually won't get anywhere close. So it's a different type of vehicle. Okay, talking about Bible science, the Bible said that the earth was spherical in Isaiah 40:22, as we saw. The earth was a flat disc, was what science used to believe up until 15th, 16th century. Now, yes, science agrees that the earth is spherical. You know, when Galileo Galilei took up his telescope, he said, I've counted all the stars, and they are about 1,100 stars. And Galileo, get a bigger telescope, because the Bible has said in Jeremiah 30, or read your Bible. Jeremiah 33:22 says that they're innumerable stars. In fact, when God promised to Abraham, I'll make your descendants as much as the sand and the seashore and the stars in the sky, God was saying your descendants are going to be, you won't be able to count them. Galileo, read your Bible. A great Palestinian singer in the 70s and 80s, Feiruz, sang a lovely song about Easter. It says, the one who hangs the earth on nothing today is hanging on a tree. I'm not going to do a Feiruz impression, but she's an amazing voice. The idea that the earth floats on nothing is mentioned in the Bible. Job 26:7, the earth floats on nothing. The idea of gravity. Science believed, actually not science, who knows, in Hinduism, the Vedas, what they believed that the earth was levitated on. 4 elephants. 4 cosmic elephants. Each of those elephants has a name, by the way, Father. What are the elephants standing on? A big cosmic turtle. Well done. Now we understand gravity a bit more. And that's the same thing that we're trying to... This is what the Bible has always said. It's like, I'm telling you what things are. Each star is different to every star in glory. We read that on Easter Day, the evening, Saturday night, before we wake up to Easter Day and have our meat. Each star differs from every other star in glory about the resurrected body. We thought stars were all the same. It's only now that we realise that there are different stars and everything is different from everything else. We could go forever on this. The Bible highlights aspects of reality, even though it's not a scientific book. But there are things that it says and claims. If we were just to really look at it, we'd understand that science is only just getting close to the reality that the Bible has always said it is. Because I'm running out of time, I won't go into this next slide as much as I want. In fact, I'm not going to do it. But have you ever thought about the 6 days of creation and things? That's not going to be done today. We're going to go straight into evidence for fine-tuning. Mark, what was your question? Can you remind us?
So basically, the Big Bang, what we're trying to do at first is prove that there is a starting point, and hence we have a creator for this starting point. But then, in essence, when we say an explosion, is that random, or is there like a perfect design for that, and was it all planned?
And that's the question I want you guys to think about as we go into this next bit. Does the next bit that I'm going to show you show that there was a design behind the universe, or was it chaotic? So if the universe had a beginning, we can say it had a creator. Can we? This will add to it. So let's go into this fine-tuning bit. You see, the evidence for fine-tuning that we're going to look at and see is going to be like how, I don't know if you've ever seen people that actually do this as a hobby or as a living. I don't know if they get paid for it, where they balance stones and they make them balance. I would go crazy. I'd like, take one, I'm not doing this anymore. It's so annoying. Our universe is so finely tuned as to be unbelievably irritating in its being accurate. As a scientist, let me try and show you what some of those finely tuned arguments are. So that's why the board is here. We're going to go into a bit of drawing and science, but the laws of physics and everything I'm going to show you is so finely tuned you wouldn't believe it. And if at the end of this talk you still aren't convinced, then do tell me. That's going to have to be one of your questions. I'm sorry, Chris and Father, some of these slides I'm skipping, and I shouldn't even be looking at a PowerPoint. I use it as a crutch to demonstrate, as a reminder of me, what I need to talk about. Going back to this slide, there's something that, one of the things that I'm going to show you later is that the universe got its fine-tuning in the very first minutes, and maybe even the first second after the creation, after the big creation, if it was a Big Bang. It was so finely tuned at that point, if it was slightly different one way or the other, we wouldn't have stars, galaxies, no planets, no life. And that was determined in the very first microseconds in that explosion. How? Let me go into that detail in a minute.
Is that the scientist says?
Yes. I'm going to show you the evidence. We're going to start with some... You remember this book I told you about, The Goldilocks Enigma, by an atheist called Paul Davies? If I was local, I would have bought all my books and you could see them and see. But Paul Davies' Goldilocks Enigma. Goldilocks being the fairy tale type character that goes and gets irritated by she irritates the three bears because she goes into their house and she sits on the chair, but one chair is too small, one chair is too big, one chair is just right. And the porridge, one porridge is too hot, one porridge is too cold, one porridge... I'm not going to explain to you this childish story, but that's why he called this book The Goldilocks Enigma. For him, the universe is just right to the point that it infuriates him as a scientist. Why is the universe just right? Why did that ball land in our backyard? Can you really not believe that it was because of the guy next door that God exists? Excuse me. What we're going to look at now needs a quick revision of our maths. So we're going to be using standard form to represent numbers. And this is a point that some of you are going to get really annoyed. But if we have 6 zeros after 1, that's 10 to the 6. 9 zeros is 10 to the 9, etc. And if we have 1 divided by, i.e. 0.000001, depending on it's that accurate, it will be 10 to the minus 6, 10 to the minus 9, 10 to the minus 12. If you're not interested, fine. But that's just, I've helped you out, and I'm not going to help out anymore. So let me explain. We're going to be looking at some of the forces in nature. The force of gravity, weak nuclear force that holds protons and electrons together. We're going to be looking at the strong nuclear force, that compounds together, the strong nuclear force that holds protons and neutrons together. We're going to look at electromagnetic force of electricity and magnetism. And now we're going to say, has anyone got really good handwriting? I don't believe any guy that's got their hand up. All right, come and show us. Could you help? So we're going to write on the board.
Ask him first if he's a doctor.
Yeah, are you a doctor?
I am.
Oh, come on!
No, wait until you see.
Okay. You're going to write definitely a doctor.
I am.
Just write for shorthand, force of gravity, or whatever we go into, and then with the black pen, and with the purple, write the number 10 to the minus 9. You'll have about 6 or 7 different items, so about that size. And then we're going to do some maths in a minute. So how accurate does the universe have to be? So I'll explain what I mean. Before we go into that, someone Google, how many particles are there in the universe? How many fundamental particles are there in the universe? Almost. I exaggerated that. So can you write number of particles? And then they're going to give you a number. How many particles are there in the known universe? How many?
17.
Huh?
It says.
17 is not the right answer.
I know. Wow.
Huh?
1080.
1080.
Number of
In the observable.
1080?
No, it should have a number, something times 10 to the... Yeah. 1 times 10 to the 78.
1 times
10 to the 78.
10. So just the
Actually,
78, just
10 to the 86 is what my Google says. Elementary particles, 10 to the 86. Yeah?
10 to the 98 is it?
Can we put...
86.
Yeah, my maths is 10 to the 86. Sorry.
What does it mean, like number of particles?
What does it mean? So elementary particles are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, elementary particles. But the particles are the thing that makes up those elements. So we're not talking about nuons and muons and all this. We're just talking about protons, neutrons, electrons, elementary particles. The things that make up elements. But now science has understood that there are things underneath elements that make up the protons, and we won't go that far. 10 to the 86, yeah? The universe is so finely tuned that the ratio of electrons to protons, if it was one way or the other, we wouldn't get electromagnetism would dominate gravity if it was larger, preventing galaxies, stars, and planet formation. So if there's more electrons than there are protons in the universe now, we wouldn't get galaxies, let alone stars, let alone planets. And if it was smaller, the same. There would be no stars, no galaxies, no planets. But how accurate, if I divide protons by neutrons, can I be slightly off? How accurate do I need to be? The answer is, if I'm off in that ratio by 0.000000037 zeros 1 over 10 to the 37, ratio of electrons to protons. So yeah, electrons, protons, 10 to the minus 37. If it's slightly different, one way or the other, we don't have life. In your head, you've got a number, 10 to the 86 elemental particles, just to give you perspective. All the particles in the universe are only 10 to the 86. But if my number of electrons to protons is one way or the other by 0.00010 to the 37, then I don't have stars or galaxies or life. Any comments on that?
So these particles exist in this cosmological egg, or like that?
That was the question that Father said. No, so if you go back to, they didn't exist at the point of the Big Bang. They would have been created because of energy creating enough hydrogen at the point of the explosion. Then hydrogen later would create helium by the coalescing, and you'd have radioactive collisions, and then you get helium, and then you get lithium, beryllium, boron, and in big stars, you'd get the formation of the much heavier elements, boron, carbon, nitrogen, oxygen, fluorine, neon. But at the beginning, you'd have only had hydrogen and helium, and then as you get more and more powerful reactions, then you would create the elements. At the beginning, it was just a big energetic explosion with no particles, no elements at all.
So does that mean that balance need to create this?
Yes, that balance is in our universe now, wasn't in the universe then. If it's slightly different, no life. Chris, help me out.
What if, right, say God had a go at the beginning and he got it wrong and it wasn't in balance, so we're not here.
Yeah.
That doesn't matter, you can bin that experiment and then another one. Say he's 30 years old, he gets it right, and then we're all here.
I totally agree.
He's just got lucky.
Maybe. Not really. Let's see how lucky he's got.
Okay.
Sorry, can I ask, how do you come up with these numbers?
You can Google them.
No, I know.
How does science
The
come up with these
science.
numbers?
I didn't know the science.
So science began to see if the ratio of electrons to protons in the early universe and now in the current universe, if it was slightly different, you wouldn't have had the higher, heavier elements beyond helium. So we're a carbon-based life form. Hydrogen, helium, you'd have had lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, oxygen, carbon, hydrogen, helium, lithium, beryllium, boron, carbon. You wouldn't have had anything close to the sixth element. You'd only had hydrogen and helium. You can't have life. And you can't have star formation without the other elements coalescing. So they looked at the ratio and they're saying, sorry, Chris.
Maybe you could have life that's not based on carbon.
Yep.
And maybe God could have done all the elements in one go at the beginning. He didn't have to just start off with nothing or do a bit of helium and hydrogen stuff.
You wouldn't have had any of the big elements at the
Why
beginning.
not? You could do some better, though.
Yeah.
Yeah.
That's the combination. That's you're right. Could
Yeah,
be right.
it could have- It could have, but that's not what science is beginning to discover.
I'm going to take that one from me.
So any questions on that?
You said in relation.
Yeah.
So is in relation between the imbalance and what we're experiencing now in the world about this climate change and
Not yet.
not yet.
No. That's in 4 or 5 sessions like this time when we look at climate imbalance and suffering and pain and things like that. But not in this. Alex, did you have your hand up?
Yes.
Yeah. But if the universe is fine-tuned to have all of this like nuclear
I haven't even got there yet. I've only done one. But if the universe is fine-tuned, great.
Yeah. Then couldn't you just fine-tune it differently if you're God? You can fine-tune it and make different laws of physics.
That's exactly Chris's question. I think you guys should continue to sit next to each other and not confuse me. That's exactly Chris's question.
I hope that there will not be.
So the question is, are they related as well? Is another question. Does it have to be that way? But, is it the only way it can be? So we'll get to that. Tell me if we don't, and if we don't, then I didn't do a good job. But let's see. Thanks, Alex. The ratio of the electromagnetic force to gravity. So the ratio of electromagnetism to the force of gravity also. So we know electromagnetic force, it's a defined value. It's got a defined strength. And gravity has a defined strength. If gravity was lower, I would be much lighter and it'd be really good because I would have done a good job of losing weight without doing much work. And if electromagnetism was much heavier, then the hair that I don't have on my head would stick out further up. Yeah, it's those things that we're relating. Electromagnetic force, gravity. If it was slightly different, but how slightly? It needs to be exactly 1 over 0.0004 zeros 1. If it's one way or the other, this is what happens. Chemical bonding, if greater, would be disrupted. Elements more massive than boron, hydrogen, helium, lithium, beryllium, boron, would be unstable to fusion. You wouldn't get stars. Galaxies, planets, life. If less chemical bonding would be insufficient for life chemistry as we know it. And it has to be within that fine element that it has to be exact. If it's slightly different, 1 over 10 to the 40, so electromagnetic force divided by gravity, or colon gravity as you put it, 1 over 10 to the 40. Let's carry on. The expansion rate of the universe. The rate at which the universe is expanding is something linked to the cosmological constant, but it's not exactly the cosmological constant. I'm not going to go into what the difference is, because it's quite difficult. If larger, so the cosmological constant is, did I have an explosion at the beginning that's like, or did I have a with a huge force? That's the cosmological constant. The expansion rate is linked to this, but completely different. It's, if I have an expanding universe, should it be expanding at this rate, or should it be really going very, very far, spreading out at 100 million miles an hour, or should it be 200 million miles an hour? What rate and speed do things move away from each other? If things are moving too fast away from each other, then you wouldn't get galaxies forming close to each other because they'd be too far away. And if smaller, the universe would collapse before you had time. So if we don't expand quickly enough, the universe would collapse back in on itself with gravity. Remember, Einstein found there's a link between the cosmological constant that says that that's the thing that keeps the universe from collapsing in on itself. So if we can write expansion rate of the universe, has to be 1 to the 10 to the 55. The mass of the universe, if you were to Google it, you'd find that the mass of the universe has to be not too massive and not too light. So if you've got 10 to the 86 particles, they have a weight, they have a mass. And that's how scientists can calculate the question that Irina was probably going to ask me. Sorry. But how do you know how heavy the universe is? I don't, but some scientists have bothered to calculate if I've got 10 to the 86 particles times by the weight of an electron, the weight of a proton, knowing the ratio of electrons to protons, I can work out how big the universe, how massive the universe is. But more than that, if the universe is slightly less massive or slightly more massive, this is the effect. Overabundance of deuterium, deuterium being, is it heavy hydrogen or heavy helium? Hydrogen 2 or helium 2? Thank you, Habibi. So I would get too much heavy hydrogen, and I wouldn't get the reactions that I would need in stars. They would burn too rapidly. I wouldn't get stars, I wouldn't get planets, I wouldn't get galaxies, all the same thing again. And if smaller, insufficient helium from the Big Bang would result in a shortage of heavy elements. I wouldn't get some of the heavier elements. These are all things you can Google, you can check, and these are things that boggle scientists now. And I'll show you some quotes from real scientists as to how finely tuned our universe has to be. Is anyone Googling this, by the way, and finding out what I'm saying is right? Please do. Let's see. So, 3 items. Massive universe, 10 to the 59, and cosmological constant. The cosmological constant is the most accurate, except for one thing. It has to be within 1 over 10 to the 120. The power of the Big Bang, if it's slightly less or slightly more powerful, if it's more powerful, you won't get stars or planets forming. If it's not powerful enough, the universe would have collapsed in on itself. That was the whole idea, that Einstein, in his formula, found that the universe had to be just right, and he created something called the cosmological constant. And he thought that that was the thing that pushed against gravity, and gravity was trying to bring us back. Georges Lemaitre said, actually, you've got something here, Einstein, but it's not a physical thing that's pushing against gravity. It's just the force of the explosion at the beginning of the universe. It's got the same value. It's valid. Your maths is good, but your idea and interpretation of it wasn't good. Mark.
Sorry, it's probably my lack of science knowledge, but you said earlier, based on Thomas's question, that. So I was just saying, you were saying earlier that the universe is expanding and speeding up.
Yes.
So how does that relate to, the speed at which the expansion is occurring, and if it's changing, like you're suggesting, how does that kind of affect?
So the cosmological constant is still a valid argument, but it's also a multiplier of type of matter interacting with antimatter, and it is speeding up. So we're not expanding the same way that we used to. Back then we're actually expanding faster and faster. And what scientists are finding is that the reason for that totally goes against our thinking. Surely at the beginning is the only thing and we should be slowing down. Actually, as we've done the expansion, some chemicals are hitting other chemicals and they're creating their own chemical reaction that's propelling us faster and faster and faster, and we're expanding faster than we thought we were. And the longer history goes on, the more that expansion speeds up. But it's still correct with the idea of the cosmological constant, but you have to add in the reactions as well. But it's one of the difficult things that science is trying to look at now. So if anyone wants to study cosmology, that's probably what you'd be asked to research.
I have a question.
Go for
So, you said at the beginning there was no space, there is no time, there is no energy,
And no matter.
and no matter. So how come that Big Bang happened
Yeah,
without something to ignite this and
yeah,
to cause this
yeah.
dispersion?
Science doesn't have an answer to that. Science doesn't have an answer. Stephen Hawking said, don't ask me what happened to cause the Big Bang. Don't ask me what happened before the Big Bang. I showed you the quote. Science fails to answer anything because physics doesn't have a formula, you can't apply it when there's no space, no time, no matter, no energy. You can't. And that's why if you were to ask an atheist, do you believe the universe had a beginning? If so, what was the cause? It becomes a very easy discussion from that point, that you can have actually a good discussion with someone. But that was talk number one. Talk number two now is, and it's so finely tuned. So who's good at maths? Who can add those probabilities?
I was good at
Alex, what do you do when you say this probability and that probability at the same time?
You multiply them.
Yes, you multiply them, and when you're multiplying surds like that.
I can see it.
Brilliant. Absolutely right, Alex. Well done. So you have to add 86. Can you do that, please? 86 plus 37 plus 40 plus 55 plus 59 plus 120.
320 something.
Well done, 320 something. Help him out, someone. But no, not the first one. Yeah, not this one.
Not the 86.
No,
No, right.
that's just.
So starting from 37.
Yeah, this just gives context to us. Just these guys. I'm going to ask you a difficult question in a minute, Chris. It's the next slide. It's a mathematical question.
300. 300.
It's only difficult because I've forgotten my maths, but you'll know it. I know! That's how my maths is.
301, 302, 303? Something like that?
1-1.
Can you write that here? 1 divided by 311. So the whole universe so far has to be accurate to 1 over 10 to the power of 311. How many particles are there, elemental particles in the universe?
10 to the 86.
So imagine if I had a powerful laser and I wanted to hit a certain particle out in Alpha Centauri, and it's on the moon and it's in that particular place. And it's a powerful laser and I want to hit and aim and hit that exact particle. I've got a 1 in 10 to the 86 chance. if I've got a powerful laser that can touch any particle in the whole universe. This is more difficult than that, because this is 1 in 10 to the 311. I'm just trying to put things in context. It's unbelievably precise. You know, that example of rocks upon rocks upon rocks upon rocks, it's unbelievably precise. Now, something that blows all these numbers out of the water. Sorry. Go for it, Harry.
Calculate the number of particles in the universe.
How do you calculate the number of particles in the universe? Apart from looking at Google, they look at the size of the universe, they look at the age of the universe, they look at the number of particles in a certain area that we know, and they multiply the potential, and they get a pretty accurate figure.
If the universe is always expanding, then aren't there always more and more particles?
You're absolutely right. They are, more and more particles are, the fundamental particles don't get created, but the elements are expanding, so the universe isn't creating more matter. The matter that you had at the beginning is still the same matter that you had at the end, but that matter-energy ratio is changing, and so you can still say 10 to the 86 protons, electrons that are now forming gold, but in the future they might form iron, and in the future it changes, yes, but it's still fundamental particles. Protons, neutrons, electrons are still the same. But how they got it, my science sort of fails to figure out how they actually got that figure. Sorry. But I'll find out maybe for next time. There's a figure that is so unbelievable that I want to ask Chris how you write this one. So this is called Roger Penrose, who's another British physicist that Chris probably knows and I know as well. He's a British physicist, calculated the initial state of the universe at the point within 1 second of the explosion. It's so finely tuned to an exquisite degree. Remember I said energy changes to mass, and that was part of the question that you just asked me? To what degree do I need to be having the right ratio of mass and energy? This is the degree, 10 to the 10 to the 123. How do I write that as a 10 to the actual number? Is it 10 to the 1230, or is it something else, Chris? 10 to the 10 to the 123.
Is it you multiply it by 10?
Multiply
Yeah.
them by 10.
Is it just 10 to the 1230? Do I just add a 0?
I think you should show it afterwards.
That was Roger Penrose. He was showing off. Why can't you give me a proper survey? Just give me a proper number.
That's why 10 to the 123, and then add it to the
Another 0. So can we have plus? So 10 to the 1020, 10 to the 1230, 1230. Yeah, and if you add this to that, you get an approximate number of 12541. It's a huge number. If I was just writing number of zeros, if I wrote 3 zeros at a time, in a second, 3 zeros a second, I would miss my train. So would you, Father. It would take us ages to just write the amount of zeros.
do that tonight.
I don't want to do that tonight.
1,230 zeros.
Yeah, it has to be accurate to that degree, otherwise you'd have too much mass or too much energy, and the universe would fail to exist. Look up the Roger Penrose number, 10 to the 10 to the 123. It's unbelievable. Thank you so much for doing this with us. Thank you so much. Yeah, your handwriting. And the handwriting is readable. That deserves another clap for a doctor. Thank you.
We're expanding.
Stefan. That is the ratio of mass to energy in the early universe, in the first second of the universe. Any other questions on that so far? Let's have a look at a video that does it a lot better than me, but without some of the maths.
From galaxies and stars, down to atoms and subatomic particles. The very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully dialed to an astonishingly precise value, a value that falls within an exceedingly narrow, life-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. There'd be no stars, no life, no planets, no chemistry. Consider gravity, for example. The force of gravity is determined by the gravitational constant. If this constant varied by just 1 in 10 to the 60th parts, none of us would exist. To understand how exceedingly narrow this life-permitting range is, imagine a dial divided into 10 to the 60th increments. To get a handle on how many tiny points on the dial this is, compare it to the number of cells in your body, or the number of seconds that have ticked by since time began. If the gravitational constant had been out of tune by just one of these infinitesimally small increments, the universe would either have expanded and thinned out so rapidly that no stars could form and life couldn't exist, or it would have collapsed back on itself with the same result: no stars, no planets, and no life. Or consider the expansion rate of the universe. This is driven by the cosmological constant. A change in its value by a mere 1 part in 10 to the 120th parts would cause the universe to expand too rapidly or too slowly. In either case, the universe would again be life prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd, the universe would be hostile to life of any kind. The fact is, our universe permits physical, interactive life only because these, and many other numbers, have been independently and exquisitely balanced on a razor's edge. Wherever physicists look, they see examples of fine-tuning. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that
Just a sec. You saw the quote from Stephen Hawking? Stephen Hawking, atheist, saying the remarkable fact is the universe is so finely tuned. David Deutsch, physicist at Oxford, also an atheist, says if anyone claims not to be surprised by the special features the universe has, he's hiding his head in the sand. Don't just let these quotes go by. This is what scientists are saying they're discovering. What they're not agreeing to is the ball belongs to the next door neighbor who, God exists. I'm not going to listen to that. It must have come from somewhere else. Do you get me?
universe has. He's hiding his head in the sand. These special features are surprising and unlikely. What is the best explanation for this astounding phenomenon? There are 3 live options. The fine-tuning of the universe is due to either physical necessity, chance, or design. Which of these options is the most plausible? According to this alternative, the universe must be life-permitting. The precise values of these constants and quantities could not be otherwise. But is this plausible? Is a life-prohibiting universe impossible? Far from it. It's not only possible, it's far more likely than a life-permitting universe. The constants and quantities are not determined by the laws of nature. There's no reason or evidence to suggest that fine-tuning is necessary. How about chance? Did we just get really, 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 really lucky? No. The probabilities involved are so ridiculously remote as to put the fine-tuning well beyond the reach of chance. So, in an effort to keep this option alive, some have gone beyond empirical science and opted for a more speculative approach, known as the multiverse. They imagine a universe generator that cranks out such a vast number of universes that, odds are, life-permitting universes will eventually pop out. However, there's no scientific evidence for the existence of this multiverse. It cannot be detected, observed, measured, or proved. And the universe generator itself would require an enormous amount of fine-tuning. Furthermore, small patches of order are far more probable than big ones. So the most probable observable universe would be a small one, inhabited by a single, simple observer. But what we actually observe is the very thing that we should least expect: a vast, spectacularly complex, highly ordered universe, inhabited by billions of other observers. So even if the multiverse existed, which is a moot point, it wouldn't do anything to explain the fine-tuning. Given the implausibility of physical necessity or chance, the best explanation for why the universe is fine-tuned for life may very well be it was designed that way. A common sense interpretation of the facts suggests that a super-intellect monkeyed with physics, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question.
So Fred Hoyle was an atheist. And he wasn't just an atheist, he was an atheist that challenged Christians to debates on radio, and he challenged Christian scientists, and he challenged everybody to the idea that God doesn't exist. He began doing some research into how easy is it to have carbon in the universe. And he found that it's really difficult and that it requires fine-tuning to a degree that was unbelievable for him. And he became a Christian, and this is his quote. This is the background to someone who was an atheist scientist who challenged for 15 years as a professional atheists, Christians in debates. And he would challenge C.S. Lewis and others. And then he became a Christian. A common sense interpretation of the facts suggests that the super intellect has monkeyed with physics. That there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put the conclusion almost beyond question. That's why I became a Christian. Put that bit underneath. Because that's what he did. He staked his life on it. His belief system changed.
There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming.
Anna wrote a book on it, he says, and I still don't believe in God. How? It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. Quite sad.
The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge.
Any questions so far? Steph?
If there are multiple universes, if the universe is infinite,
Yes.
then surely one would work.
Yes. And we're just in that right now. This is linked exactly to the question, Chris. Absolutely right.
But then I think we said that it's not observed, but then surely someone would say that we don't know
So,
about all the stars and that.
do you watch The Big Bang Theory? Put your hand up if you know who Sheldon is from The Big Bang Theory. Okay, this is a comedy that's been going on for years, and it's like reached 10 seasons or something. Sheldon from The Big Bang Theory studied string theory as an amazing scientist that's got very big quirks about his character. But he studied string theory in order to show that multiverse existed. And what they find is multiverse theory, can't lead to any results because it's not supposed to be observable. It's a theory that doesn't have any observable, it's pure theoretical. And you can't observe it, you can't see it, you can't test it. There is no evidence that we know of and no way of testing evidence to suggest multiverse theory. And even if it did exist, the idea that a multiverse would be spewing out multiple different universes to the degree that we're talking about, even if it was infinite, breaks down in these kind of astronomical, accurate figures that we're talking about. I could go into that, and I do in part 3, which is after our next break, when we look at the improbability of life. But Sheldon, in the series, about series 6 or 7, he gives up string theory, and he says, this is not leading anywhere, and he starts to look at something else. It's a lovely comedy that I really enjoy. Chris?
Just on the probability one, if something's got a probability, it's likely to happen on the first go as the nth go for each one and
Say again.
Probability. If it's got a probability of 1 in whatever,
Yes.
it's just as likely to happen on the first go as any of the other opportunities to have that.
Absolutely. But as a scientist, as an engineer, as someone with a logical mind, we can also look at something and say, what's the likelihood of this ball coming from next door?
I think we've covered that one. It was Danny's ball.
It was Danny's ball! And it's God's creation.
Okay.
These are the kind of questions that you will get asked and you have to think. And if you've got a probing mind like Chris and Alex and others have expressed, and Sherry and Irene and Thomas, then that's what leads to you being the next set of scientists. Aborna Michael used to be, before becoming an Aborna, an amazing geneticist that was finding the reason for cancer and beginning to create cures for it. And he's going to probably come back, if you invite him, to do a talk on evolution and other things. But we're not meant to be mindless believers that don't question. Let's be people that make things real for others as well. Thomas?
You use some of Stephen Hawking's quotes and you use that in a way that proves what we're saying here. But he was really adamant that God didn't exist.
Yep.
To the very end. Why was he? Do you know what was his belief in why God didn't exist?
Thomas?
So he's more likely to even.
Yeah, Thomas, that's a brilliant question. Let's listen to how he explains it, and you tell me what you think of this quote. Now, granted, Stephen Hawking wrote this in a book, the last book he ever wrote, just before passing away. But this was his answer to what he now believed just before dying. In the book, The Grand Design, he states, you guys are going to need to answer this question for me. What does this mean? Because there is a law like gravity, the universe can and will create itself out of nothing. Spontaneous creation is the reason there is something rather than nothing. It is not necessary to invoke God. No.
This one?
Yeah, I read it wrong. No, we read it again for us. We just had it in the video as well. That's amazing. No, please.
I was not here, so that's fine. You
No,
read
no.
it, that's fine.
Romans 1:28 says,
And even as they did not like to retain God in their knowledge, God they gave them over to the debased mind to do those things which are not fitting.
oh yes, I thought you were going to raise the verse before. Yes, but that's a lovely verse. In Romans, it made it so clear that we're without excuse. But now it leads
They don't want to retain God in their knowledge, and that's what they wish.
Abuna, you're a scientist in background. Please explain this to me. Because there's a law like gravity, gravity, a law can't create itself. You create the theory of gravity based on what you see and notice, and then you say this is how things are working. If you've got nothing to see and investigate, the law doesn't create itself. Because there is a law like gravity, the universe can and will create itself out of nothing. How? Does that make sense? Anyone here?
Some sort of circular reasoning here.
Yes. So
where's the material? The gravity does not have the law of gravity does not have the creation of the material.
Some good minds. Alex, Chris, you've been asking me questions. Please explain this to me. Has he got grounds? Does it make sense? Am I missing something?
Might have had a drink too many that day.
So, just before passing away, he was really into this M theory, which if you look at it is string theory, but looking into M theory within string theory. And he'd spent 15, 20 years looking into M theory. And he says, according to M theory, ours is not the only universe. It predicts that a great many universes were created out of nothing. Honestly, hand on heart, look up M theory. Can you observe? Can you see? Can you test it? Can it be measured? Has any test measured it and seen and shown results? And then come back and tell me.
I get the part about the...
Oh yes, please. Tell me, what does this mean?
I get a bit about spontaneous creation, where he's saying that if there is an infinite number of universes...
Oh no, that's that bit. But what about this?
The second sentence of that bit, spontaneous creation is the reason that's thing rather than a thing. If spontaneous creation is a thing...
But it isn't a thing. You can't just have things come out of nothing.
What he believes, I don't...
He believes that spontaneous creation happened from nothing because there is a law like gravity. These laws explain what the universe is, but it can't bring the universe into existence. Yeah? Physics is the result of you observing how the universe works, but it can't be the reason that the universe begins from nothing itself.
It's the dream of the poor that one day he will have millions pounds in his bank spontaneously. It's the dream of the poor.
It's the dream for all of us.
The Oxford chemist. So I'm getting to your question, Tom. That is your question, right? How does Stephen Hawking explain it to himself? Oxford chemist Peter Atkins says, space-time generates its own dust in the process of its own self-assembly. Mathematics created the universe.
Who created mathematics? Because of
So,
the cause.
in science, this is called the cosmic bootstrap principle. Anyone know what the bootstrap argument is? The bootstrap...
Alex, get it now.
Sorry?
Alex has got it.
Alex, wow.
Just putting yourself up by your bootstraps.
Wow, brilliant! Pulling yourself up by your bootstraps. So imagine if you could pull yourself up by your bootstraps, lift your bootstraps, pull yourself up, but to the point that you're levitating off the ground by pulling yourself up on your bootstraps without jumping. It can't be done. And it says that the universe came into existence by pulling yourself up by your bootstraps, creating the universe from nothing because mathematics exists. It's called the bootstrap argument. It used to be the way of making fun of other physicists. Physicists would make fun of another physicist and saying, that's a circular argument, Mark's comment, I think it was Mark, and it's called, it's bootstrap argument, that's rubbish. Now the bootstrap argument, apparently, is a good thing. That's the reason. It isn't. Okay. I go into why it's contradictory, but I want to show you some quotes. Alan Sandage, one of the most influential astronomers in the 20th century, writes some of these quotes that you saw. I find it quite improbable that such order came out of chaos. There has to be some organizing principle. God to me is a mystery, but is the explanation for the miracle of existence why there is something instead of nothing. Einstein says, look, I'm not an atheist, and I don't think I can call myself a pantheist, someone who believes in many gods. In view of such harmony in the cosmos, which I, with my limited human mind, am able to recognize, there are yet people who say there is no God. But what really makes me angry is that they quote me for support of such views. What gets Einstein angry is that people are using him to support the idea that God doesn't exist. He himself believes in God. And he goes on. Okay, I'll read you some of those. My God created laws. His universe is not ruled by wishful thinking, but by immutable laws. I don't know if you noticed the readings of today's readings from St. Paul, from Timothy. It talks about a design. It talks about the universe being created just right. It talks about a designer. My God created laws. I want to know how God, this is the inspiration why many scientists who were Christian studied science. They wanted to know, how did God make things? There must be an understanding. God is ordered and he's a designer. Can I understand something of the way that God has made the universe? So he says, I want to know how God created this world. I want to know his thoughts. That's why he studied physics. Who's that? Richard Dawkins. This isn't Richard Dawkins. This is Charles Darwin. But Richard Dawkins is a new atheist. He calls himself Neo-Darwinians. And they argue against any belief in God. And they write books such as The Blind Watchmaker, which is one of his best, Selfish Gene, bit bad, okay. And now, recently, some really bad books that just don't make sense. But the first few books are really troublesome, and you have to really study them hard, because they're very well written. In his autobiography, Richard Dawkins, he quotes, in his books, he quotes Darwin as being his inspiration, why there is no God. This is what Darwin said. Sorry for this long quote. I'll try and read it fast. Another source of conviction in the existence of God, connected with the reason and not with the feelings, impresses me as having much more weight. So Dawkins is talking about, Darwin is talking about his belief in the existence of God through reason. This follows from the extreme difficulty, or rather impossibility, of conceiving this immense and wonderful universe, including man, with his capacity of looking far backwards and far into the future as the result of blind chance or necessity. When thus reflecting, I feel compelled to look to a first cause, having an intelligent mind in some degree analogous to that of man, and I deserve to be called a theist. This was Darwin's view. When you look at nature and you reason, you come to the realization that God exists. I'm not going to keep quoting. We'll end here for a break, but with some questions, and then we'll stop. How am I going to cover that in the next bit? Any questions so far? We'll see.
I have a very philosophical question.
Yep.
So, if we believe now that God exists and the science supports that.
Wait, start from the beginning. If we believe the universe had a beginning, and if we believe the universe is so finely tuned for life that it's beyond improbable to be chance.
So, why God would allow people to have these discoveries and reach a stage where they would think that there is no God, you could create anything from.
Why would God allow it?
Free will.
Yeah.
That's exactly how he made us. Have you got any pets at home? Anyone got a fishbowl at home? Yep. 2 fish bowls. You used to. What do you need to provide for a fish in a fishbowl to make the fish live a bit longer?
She did very easy, that's what
This is my kind of thinking.
Chris, gosh.
So, what do fish need to exist? Food, water, and a cleaner tank. You need to clean it once every 10, 20 days. What do wild wolves need to exist? So, a slightly more complex being, wild wolves, what do they need to exist? They need to hunt, they need prey, they need to feel that they're fulfilled by biting into juicy red meat that just is hot and drips, and they've had to work hard to find it, and that keeps them happy. What else? Huh?
To feel warm.
To feel warm. So they build dens and they sit around and sleep next to each other. What else do wolves need? Water. So everything that the fish need, water and food and an environment. What else?
Family.
Oxygen and family. Brilliant. So wolves need a more complex family environment, and they have a hierarchy as to who is the head wolf and who is, the subordinates and who are the young ones that are learning, and pack mentality. Yeah? And you need wide spaces. You need places for them to hunt and to feel that they are able to run and to enjoy it. More complex than a fish. Now with man, what does man need? So going back to something called Maslow's triangle of pyramid of needs. At the top, love and self-worth. At the bottom, all the things that an animal needs in terms of life and feeling secure and food and all these things. But right at the top, you get the idea of fulfillment and satisfaction. Man wants to have the exhilaration of studying something that was unknown to people, and because of their study, they've understood now how macroorganisms work, and they've been able to break down an electron and a proton and found that its other constituent particles exist, like muons and nuons, and and we love finding out things that haven't been found, from the very small to the farthest end of the galaxy. Man is still searching. Why? Because God knows that that's what satisfies man, and he's built such a complex universe for us that 400,000 years maybe since we've been on the earth, we're still discovering more about the universe. Because that's the mind that God has given us, and we're still satisfied, and we're still learning new things. So why has God allowed us to discover things? Because he's made us to have a mind that can either look to him, or that can freely decide not to look at him. Without that freedom, we wouldn't be who we are, and we wouldn't be able to turn around and say, we love you, we want to get to know you better, we want to be in a relationship with you freely. Because you've given us the possibility to turn away from you, and the possibility to turn towards you. Does that cover some of the...
Yeah.
Thank you. Sherry? Please. Okay, should we stop here? We'll have a 5-10 minute break. 10 minutes. Please come back in 10 minutes, because this next bit is big. Sorry?